Welcome to the Deep Dive. This is where we unpack the fascinating insights hidden in your submitted sources, helping you get truly well-informed, without feeling overwhelmed. Today, we're setting sail on a really incredible journey across the vast Pacific Ocean. We're tackling one of those questions that just boggles the mind. How on earth did Polynesian navigators find those tiny islands, so incredibly far from anywhere else? We've got a great set of sources for this dive. There are bits from a pretty lively Reddit thread digging into Polynesian wayfinding, a detailed Wikipedia entry on those unique Marshall Islands stick charts, and even a National Park Service document that looks at navigation through time, with some cool modern comparisons. So our mission today, to unpack the truly ingenious methods, the frankly remarkable vessels, and the compelling history of these master mariners. We want to pull out the key pieces of knowledge that really show their unparalleled skill and courage.
Absolutely. And what you'll find is this wasn't just luck. It wasn't just drifting aimlessly. Polynesian navigation was, well, it was a sophisticated science developed over thousands of years. It relied on this incredibly holistic, almost embodied understanding of the natural world. We're going to explore how they read these tiny, subtle cues and their environment cues that, honestly, most of us today wouldn't even notice, glued to our phones as we are. And this knowledge, this deep connection, allowed them to populate nearly every habitable island across the Pacific. We're talking the largest ocean on Earth, long before European explorers dared to sail out of sight of land. Get ready for some genuinely surprising facts, I think, and hopefully a real appreciation for this ancient ingenuity. It's still something that challenges our modern understanding.
Okay, let's dive into this. When we think navigation, right, our minds jump straight to compasses, paper maps, maybe the GPS on our phone. Standard stuff. But the Polynesians, they had none of that. Zero. Yet they cover thousands of miles of open ocean, not just once, but reputedly, setting up whole new societies. How? It turns out they read the ocean and the sky in ways that, frankly, seem almost magical to us now. They essentially turned the huge, seemingly empty Pacific into a kind of living map.
That's a great way to put it. What's so fascinating is how they took this seemingly featureless expanse of water and turned it into a dynamic, really comprehensive navigation system. It wasn't about external gadgets. It was about incredibly refined perception, skills honed over generations, passed down through oral traditions, chants, stories, direct teaching, and this, well, almost symbiotic relationship with their environment. They basically turned their whole world into this living, breathing map, sensing tiny details that told them exactly where they were and which way to go. It engaged every single sense. It was a different kind of intelligence, really.
Okay, one of the most maybe mind-blowing methods mentioned in our sources, and maybe the hardest for us to really get our heads around, is their understanding of waves and swells. This wasn't just about, big waves coming. It was about understanding how distant islands, maybe hundreds of kilometers away, subtly changed the patterns of the ocean. Can you imagine? Knowing an island is over the horizon not because you see it, but because you feel its effect in the water under your canoe. How did they even do that?
Precisely. It sounds incredible, but they had systems. The Marshallese, for instance, developed this incredibly detailed system for identifying and reading four main types of ocean swells. Each had its own name, its own character, its own origin. So first, they recognized the rilib. They called it the backbone swell. This is the strongest one, the most consistent, generated by those powerful northeast trade winds. It's there year-round. Even if the local wind died down, that rilib swell would still be rolling across the ocean from the east. It gave them a constant directional clue, a baseline.
Okay, a constant baseline swell. That makes sense. What were the others?
Right. Then there's the Caleb. This one's weaker, but also year-round. Apparently, only the most experienced navigators could reliably detect it, maybe more of a secondary swell pattern. Then you have the Bungdokrik. These come from the southwest, also year-round, and down in the southern islands of the Marshalls, they could be just as strong as the Relib. And finally, the Bundoking. That's the weakest, mostly felt up in the northern islands. So you see, it's a complex picture of different wave energies coming from different directions.
Wow. Okay, so they identified these four main types, but how did that help them find islands?
Well, they didn't just note them. They observed how these deep underlying swell systems were affected by land, how they were blocked or bent refracted, or how they interfered with each other when they went around an island. Think of ripples in a pond, right? You throw a stone in, and it creates a pattern. Put another obstacle in, and the way the ripples bounce off or bend around it creates a new, unique pattern downstream. They would literally lie down flat in the canoe, press their bodies against the hull, feel the subtle pitching, the rolling, maybe even the vibration. It wasn't about seeing the waves on the surface necessarily. It was about sensing these minute changes in the canoe's motion caused by those deep ocean swells interacting with land masses that were still way below the horizon.
So they can feel the shadow of an island in the waves.
In a way, yes. By feeling how, say, the main relib swell felt slightly different, maybe a bit confused or dampened. They knew an island was probably up ahead, maybe 50 miles away. Or they'd feel how two different swell patterns crossed each other in a specific way near an island group. It was like feeling the echoes of land through the water itself, long before they could see anything.
That is just incredible. There's a story in the sources about a Hawaiian guy who was part of a cultural program sailing a traditional raft just using stars and swells. And apparently in the middle of the night, one of the elders just says, the swell feels wrong, just like that. And later they checked and found out, yeah, they were way off course.
Yeah.
That level of sensory connection, it's more than just knowledge, isn't it? It's like their bodies were the instruments.
It absolutely is. It highlights this deep, intuitive, almost embodied knowledge. It wasn't just memorizing star charts. It was internalizing this profound connection with the ocean. Their whole life was a constant lesson in reading the environment. They learned to feel these almost imperceptible changes and correct their course based on them, even near islands they'd never visited before, because their bodies were just so finely tuned to the sea's rhythms. It's really a testament to thousands of years of observation, adaptation, and relying on what we might call soft data, that constant stream of subtle information.
Okay, so the ocean itself is a map. What about the sky? Obviously stars, but clouds too. How can clouds be landmarks? They change all the time.
Well, yes and no. While individual clouds move, larger land masses, especially islands with mountains, affect the atmosphere above them in predictable ways. They can create specific, often quite static, cloud formations. Think about it. Land heats and cools differently than water. Mountains force air upwards. This creates turbulence, temperature differences, condensation patterns. So you often get these distinctive cloud banks that tend to hang over or stream away from islands.
Like a signpost in the sky.
Exactly. The Maori name for New Zealand, Aotearoa, famously means land of the long white cloud. And that's not just poetry, it's likely a navigational observation. A long, stable cloud formation indicating a large landmass. You can see this sometimes when flying. You see a fixed cloud bank long before you see the island underneath it.
I always thought that was a sheep joke growing up in Australia, but no, it's a real thing.
It's a real thing. And one source even speculates, perhaps, that a massive volcanic eruption, the Kahara eruption around 1315 CE, might have sent this huge, long, white cloud out into the Pacific. And maybe that helped guide the final migration to New Zealand, a sort of follow that cloud event.
Wow. Whether volcanic or just weather patterns, it's amazing they use clouds like that. And stars, of course. They memorized over 100 star paths.
Oh, easily. They memorized the precise points where key stars rose and set on the horizon. Each star effectively had a house or a known bearing. They weren't using sextants for latitude, like Europeans later did. They were using the stars as a directional compass. They'd steer towards a star rising in the east, and as it climbed higher, they'd switch to another star rising in the same house, maintaining their bearing. It was a dynamic celestial compass.
And even on cloudy nights.
Even then, apparently they could use just a quick glimpse of a familiar star through a break in the clouds to get a general bearing. Maybe not pinpoint accuracy, but enough to stay roughly on course. That takes incredible dedication and instant recall, a whole mental map in their heads.
It really seems like they used absolutely everything. Birds, too, like biological drones.
It's a good analogy. Yeah, they often carried specific seabirds on their voyages. Birds like frigate birds or terns, species that generally need to return to land to rest. They don't land on water for long. So if they were searching for land, they'd release a bird. If it flew off purposefully and didn't come back, that was a hugely exciting sign. Land was likely near.
And if it came back?
If it circled and came back to the canoe, well, that meant they were still in the vast emptiness of the ocean. Imagine that feeling. The hope, then the disappointment. A simple, elegant, but emotionally charged technique.
It's ingenious. And apparently this wasn't unique. Vikings did something similar.
That's right. Vikings supposedly used crows or ravens in a similar way when exploring the North Atlantic. And there are even accounts from the Sahara Desert, people using birds to locate hidden oases. It's a great example of humans cleverly using animal behavior.
Okay, this next one sounds almost mythical. The sources mention using the taste of the water. How is that even possible? Salinity.
It sounds incredible, doesn't it? But yes, apparently some navigators developed senses so acute they could detect subtle changes in water salinity, maybe even temperature or turbidity, just by tasting it or feeling it. Different ocean currents carry water with slightly different chemical signatures, think different levels of salt, maybe different types of microscopic life or sediment picked up from certain areas.
So they weren't tasting the island itself.
No, no, not directly. But they would recognize the signature of a particular current. And through generations of experience, they knew that this specific current, with its unique taste or feel, generally flowed, say, southwest towards a known island group. There's this amazing account of a blind Polynesian navigator who could just dip his hand in the water, taste it, and point towards the island. It wasn't magic. It was an unbelievable library of sensory data stored in his memory, associating water characteristics with locations and directions.
That is just phenomenal.
Yeah.
It really wasn't magic, was it? Just this incredibly deep understanding, honed over lifetimes of constant interaction with their world.
Exactly. It was a living tradition, passed down through rigorous hands-on training. Apprentices spent years at sea learning to see, feel, hear, even taste the subtle signs that we, with our instruments, have completely lost the ability to perceive. It implies a different kind of intelligence, deeply integrated with nature.
Okay, but here's where it gets really weird. Maybe even pushing the boundaries of what we think is possible. The sources mention something called tilapa, described as a flash or a streak of light seen both underwater and above water. And apparently, it could appear over 100 miles from an island as a straight line pointing towards it. What on earth is tilapa?
Ah, tilapa, yes. This is one of the most enigmatic phenomena associated with Polynesian navigation. It's described often as underwater lightning or an electric streak, this luminous line just above or below the surface. It does seem anomalous. Some more straightforward explanation suggests maybe it's just reflected light, sunlight or moonlight bouncing off lagoon water near an island, or maybe intense bioluminescence stirred up by waves hitting a distant reef.
But that doesn't explain everything, does it? Seeing it on moonless nights, or why it appears as a straight line pointing the way over such huge distances.
Exactly. Those aspects are harder to explain with simple reflection or standard bioluminescence. This has led to some more, speculative scientific theories. One possibility involves something called atmospheric ducting.
Atmospheric ducting, like
Yeah.
for radio waves.
Similar principle, yes. Temperature inversions in the atmosphere can create layers that act like a duct, bending light rays over the horizon much further than normal line of sight. It's how you sometimes see mirages, or how, famously, people in Michigan can occasionally see the Chicago skyline across Lake Michigan.
So the light from the island itself, maybe fires or bioluminescence near the shore, gets bent over the horizon by the atmosphere.
That's the idea for the above-water component. The island itself, or phenomena near its coast, acts as the light source, and the atmospheric conditions allow it to be seen from incredible distances. This is actually one explanation for the Flying Dutchman ghost ship legends, seeing a ship's lights seemingly floating way above the horizon.
Okay, but what about the underwater part? Can light get ducted underwater?
That's much more contentious. Water absorbs light far more effectively than air, so long-distance underwater light transmission like that seems, unlikely based on current physics. Perhaps the underwater description relates to the light source near the island being underwater, or maybe it's a misunderstanding of how the phenomenon was perceived or described, or perhaps it involves bioluminescent organisms responding in a chain reaction. It's still debated.
So the exact science is still a bit fuzzy.
For some aspects of tilapa, especially the underwater part and the precise mechanism, yes. But regardless of the exact explanation, the key point is that Polynesian navigators clearly perceived something, some environmental cue related to distant land that was far beyond the recognized sensory capabilities of, say, contemporary European sailors. It really underscores the depth of their knowledge, maybe even hinting at environmental phenomena that we don't fully understand yet. Tilapa remains this potent symbol of their deep, perhaps even mysterious connection to the ocean world.
Okay, so they had these incredible observational skills, this deep environmental knowledge. But that alone doesn't get you across thousands of miles of ocean to settle new lands, right? You need the hardware. You need sophisticated boats.
Absolutely. Those skills were essential, but they needed the right platform. And the sheer extent of their dispersal across the Pacific is proof positive that they had highly capable vessels. Forget the old image of crude rafts drifting randomly. Modern scholarship, looking at archaeology, linguistics, genetics, it all points towards rapid, intentional expansion and sustained contact between islands, and that simply requires advanced seafaring technology.
So when we picture these canoes, we shouldn't think of simple little dugouts.
Definitely not the voyaging ones. While dugout bases were used, especially in some regions or for smaller craft, the true long-distance voyaging canoes were complex engineering marvels, primarily built from planks.
Planks. How do they join them strongly enough for the open ocean?
With incredible skill, master builders would shape planks, often from breadfruit trees or other suitable timber, and bore precisely spaced holes along the edges. Then, using immensely strong cordage made from coconut fiber sennit rope, they would literally stitch or lash these planks together. Imagine sewing a boat together but with rope and wood. The tension had to be perfect. Then they'd seal the seams with caulking, often made from breadfruit sap, making them remarkably watertight and resilient. This technique allowed them to build much larger, more complex hull shapes than you could ever get from a single log.
And they were usually single hulls, right? For stability.
Correct. For stability, especially when using sails, you need a wider base. The most common configuration was a single main hull with an outrigger. A smaller float boomed out to one side and lashed parallel to the main hull. That prevents capsizing. But the real flagships, the long-distance voyaging and colonizing vessels, were often double canoes. Two large hulls, often nearly symmetrical, connected by crossbeams with a big platform built on top.
So like a catamaran.
Exactly like a catamaran, or perhaps more accurately, catamarans evolved from this Polynesian design principle. These double canoes offered fantastic stability, much more space for crew, passengers, water, food supplies, planting materials, animals, everything needed to start a new life far away. The platform was the living space. The hulls were for storage.
And these could be huge, couldn't they? The sources mention lengths of 15, 20 meters.
Yeah.
Even up to 28 meters for some Tongan canoes.
Oh, yes. These were substantial vessels, capable of carrying dozens of people and tons of supplies for weeks or months at sea. That description in the source, literally astronauts on spacecraft made of logs, it sounds dramatic, but it really captures the scale of the undertaking and the sophistication of the technology relative to their materials.
And they were fast, too, not just drifting.
Definitely not just drifting. Estimates suggest speeds of around 7 knots for Samoan canoes, which is very respectable. And Tongan canoes, the kalia, were reportedly even faster, maybe exceeding 11 knots under good conditions. That kind of speed is crucial if you're talking about the short chronology, that rapid expansion across East Polynesia in just a century or so. You need efficient, fast vessels to make that feasible.
They were really built for survival, too, aren't they? Mobile communities, essentially. Carrying livestock, gardens, ways to collect fresh water.
Yes, they were designed for self-sufficiency. They carried everything needed to survive the journey and establish a new settlement. This wasn't just about reaching land. It was about arriving with the means to thrive.
Now, there's an interesting technical point in the sources about how they maneuvered, something called shunting versus tacking. Can you explain that?
Right, this relates to how they changed direction relative to the wind, particularly when sailing upwind. Tacking, the common European method, involves turning the bow of the boat through the eye of the wind. It requires quick sail adjustments and often loses some ground. Wearing is turning the stern through the wind, a slower downwind turn. Shunting is different. Instead of turning the boat, you move the sail from one end of the canoe to the other. The crab claw sail, which was common in Polynesia, is designed to pivot easily. So you essentially reverse which end of the canoe is the bow and which is the stern relative to the sail and the wind.
So the boat keeps going in roughly the same direction, but the sail flips ends.
Pretty much. If this was a common technique, it implies a very mobile rig and could be a very efficient way to change tack without losing much momentum, potentially making sailing against the wind more feasible.
But is it certain they did this?
There's some debate. Some evidence suggests many Polynesian canoes did have distinct bows and sterns, which argues against routine shunting. And the highly mobile rig needed for easy shunting might have been a later development, or perhaps more common in certain areas like Micronesia. How effectively they could sail against the wind is a key part of the bigger debate about intentional two-way voyaging, especially eastward against the trade winds. Shunting, if widely used, would certainly help that argument.
Okay, fascinating stuff on the vessels. Now, maps. They didn't have paper, but they had these stick charts, particularly in the Marshall Islands. These sound completely different from any map I've ever seen.
They are truly unique, a significant contribution to the history of mapping, absolutely. Made from coconut frond midribs, lashed together with sennit fiber, with small cowrie shells marking locations. But here's the crucial difference. They didn't primarily map land features, they mapped the ocean itself. Specifically, they mapped the patterns of those ocean swells we talked about, the Rilib, Kailib, etc., and most importantly, how those swell patterns were disrupted and altered by the presence of islands.
So the sticks represented waves, and the shells were islands.
Essentially, yes. The sticks, often curved, would represent the crests of the dominant swells, showing their direction. Where sticks intersected or bent showed how swells from different directions interacted, or how a swell curved around an island. The shells mark the locations of the islands within this dynamic wave map. It's a map of interactions, of invisible forces made visible, or at least tangible.
And there were different kinds. For teaching versus actual navigation.
That's right. The sources mention three main types. Matang charts were abstract, symmetrical diagrams used purely for teaching the basic principles how an island disrupts a swell pattern, creating zones of calm or reflected waves, like a textbook diagram. Then meadow charts showed actual islands and the corresponding swell patterns for a specific section of the Marshall Islands chain, more practical for learning a particular route or area. And finally, Rebelib charts were the most comprehensive, covering most or even all of the Marshall Islands, showing the relative locations of many islands and the complex swell patterns connecting or surrounding them.
But they didn't actually take these out on the canoe with them, did they?
No, that's another key point. These charts were mnemonic devices. They were studied intensely, sometimes for years, before a voyage. The navigator had to internalize the information to build a mental map represented by the physical chart. You had to feel the swell patterns represented by the sticks while you were out on the water. The chart was a tool for learning and memorization, not an instrument for real-time consultation at sea.
And only the person who made it could really read it properly.
Largely, yes. While the general principles were shared, each chart was a personal interpretation, reflecting the specific knowledge and experience of the navigator who constructed it. It was a deeply personal cognitive tool. This knowledge was incredibly valuable, naturally. It was often kept secret, passed down through families, usually from father to son, among the elite navigators and chiefs. It wasn't common knowledge.
So how did we even find out about them?
It wasn't until the late 19th century. A German naval captain named Winkler spent time in the Marshalls and eventually managed to gain the trust of some navigators and persuade them to explain the principles behind the charts. That was when this unique cartographic system really became known to the outside world. It's a fascinating story of cultural knowledge finally being shared, revealing this whole different way of mapping and understanding the world.
Okay, so we have these incredible skills, these sophisticated vessels, this unique way of mapping. And the result was this astonishing expansion, colonizing a vast triangle of the Pacific, from Hawaii up north down to Aotearoa, New Zealand in the southwest, and way out east to Rapa Nui, Easter Island. They populated this immense area well before Europeans were doing anything comparable in terms of open ocean voyaging. But the when and why of this rapid expansion, that's been a subject of intense debate, hasn't it?
Oh, absolutely. And the narrative has shifted dramatically over time. Early European explorers and scholars, frankly, often underestimated Polynesian capabilities. They looked at the technology through their own lens and thought, well, they couldn't possibly have done this on purpose. So for a long time, the dominant theories involved accidental drift voyages, fishermen blown off course in a storm, washing up on some distant shore by chance, maybe unable to return.
Right, the long chronology idea. That settlement happened slowly, maybe haphazardly, over a really long period, maybe starting as early as 200 BCE and stretching all the way to 1000 CE for East Polynesia.
Exactly. That was the prevailing view for decades. Based on the early evidence available, some linguistic analysis, pollen cores showing vegetation changes, and the first radiocarbon dates. It seemed plausible, given the immense distances.
But that view has problems.
Significant problems, yeah. One major issue was the old wood problem with early radiocarbon dating. If you date charcoal from a big old tree used for firewood, the date tells you when the tree died, which could be centuries before human actually burned it. So it could make archaeological sites seem much older than they really were.
Okay. Giving a false impression of very early settlement.
Precisely. Plus, those early models often didn't properly factor in how quickly populations can grow. A slow, millennium-long trickle of accidental arrivals doesn't really fit well with establishing viable, thriving populations across so many islands. So with more refined dating techniques like AMS radiocarbon dating, which can date tiny samples like seeds or small twigs that were definitely contemporaneous with human activity, and by carefully filtering out those potentially unreliable old wood dates, a new picture emerged.
Which is the short chronology.
Yes. The short chronology suggests a much faster, more compressed period of colonization for most of East Polynesia places like Hawaii, Rapa Nui, the Marquesas, New Zealand. The current consensus puts this burst of expansion mainly between about 1100 and 1200 CE, possibly even within a single century.
Wait, a century to settle that vast area? That's
Mm.
mind-blowing.
Yeah.
That implies incredibly deliberate, organized, large-scale voyaging, not accidents.
Exactly. It completely changes the picture. It points towards intentional exploration, colonization, and likely two-way voyaging. They weren't just drifting, they were setting out with purpose, with the technology and the knowledge to find new lands and potentially return.
It makes you think about the social organization needed to support that kind of endeavor. Building those big canoes, training navigators, mounting expeditions.
It really does. It suggests sophisticated chiefdoms, resource mobilization, and a powerful cultural drive for exploration. But it also sharpens a key challenge: the prevailing winds.
Right. The trade winds across most of the tropical Pacific blow generally from east to west. So how did they manage to consistently sail eastward to reach those farthest islands like Hawaii and Rapa Nui? That seems like sailing directly into the wind, which is tough for any sailing vessel, let alone ancient canoes.
That's the million-dollar question, and where you see different scholarly interpretations. You mentioned Ben Finney, who was instrumental in the Hukulia project. His work, based on actual sailing experiments with replica canoes, emphasized using skill and strategy.
Like finding gaps in the wind.
Sort of. Utilizing temporary wind shifts, localized variations, sailing crosswind, maybe making short dashes eastward during brief periods when the winds reversed or slackened. It emphasizes the navigator's skill in playing the conditions day by day.
Okay, so skill and tactics. What's the other main theory? You mentioned Ethel Anderson.
Right. Anderson and others lean more towards the influence of large-scale climate patterns, specifically the El Niño Southern Oscillation, or ENSO. We know that strong El Niño events can cause major temporary reversals in the Pacific trade winds, making them blow westward or eastward for periods.
Ah, so climate change giving them a window of opportunity.
Essentially, yes. And interestingly, there's evidence suggesting a period of more frequent or stronger El Niño events around that critical 1100-1200 CE timeframe, aligning perfectly with the short chronology's rapid eastward expansion. It doesn't mean they didn't need skill, but these climate windows could have made those incredibly difficult eastward voyages much more feasible.
So it might have been a combination. Skilled navigators taking advantage of favorable climate periods.
That seems very likely. It probably wasn't easy either way. These were still incredibly risky undertakings. The sources mention this idea of an abiding faith that there was another island just over the sea under the sunrise. A powerful mix of maybe population pressure, resource scarcity, political conflict, or just sheer human curiosity driving them outwards. You have to remember, they were comfortable sailing thousands of kilometers into the unknown at a time when European sailors were mostly hugging coastlines. That speaks volumes about their confidence, their technology, and their whole worldview.
But surely they weren't just setting out hoping for the best, right? These couldn't have been suicide missions. How did they plan for getting back if they didn't find land?
That's a crucial point, and the sources highlight some very clever strategies that show these were well-planned expeditions, not desperate gambles.
Like the half-supply rule.
Exactly. The discipline involved is amazing. The rule was, when you've used half your food and water, you turn back, period. Doesn't matter if you think land is close, doesn't matter how optimistic you feel. Half supplies means turn around. That guaranteed you had enough to make it home if the outward voyage was unsuccessful.
That's incredibly pragmatic.
Anything else? Another really smart tactic mentioned is deliberately sailing against the prevailing wind or current on the outward journey when searching for new islands.
Why make the trip out harder?
Because it made the return trip easier. If you sail out against the wind and find nothing, turning back means you have the wind behind you, making the journey home faster and requiring less effort. It maximized the chances of a safe return.
That makes so much sense. It completely counters that old idea that we only know about the lucky ones who survived, the survivorship bias.
It really does. While undoubtedly voyages were lost, the Pacific is vast and unforgiving. The archaeological evidence tells a story of success. We find similar tool styles, pottery, and genetic links between distant islands, indicating repeated contact and back-and-forth movement. These weren't just one-way trips. They established settlements, maintained connections, and returned. It all points to well-resourced, well-planned expeditions undertaken by exceptionally skilled mariners who knew how to use the stars, swells, and everything else to find their way home again.
It's just amazing to think about that expansion phase. But what happened after they reached these islands? Did the canoes stay the same, these giant voyaging machines? Or did they start to change, adapting to their new homes?
That's a really interesting part of the story, the evolution of canoe design after the main settlement period. And yes, they absolutely adapted. Designs changed quite significantly in different parts of Polynesia, reflecting the local environment, the available resources, and the changing needs of societies that were now settled, not constantly exploring.
So where did they stick closest to the original voyaging designs? The sources mention central Polynesia, like the Society Islands, Tahiti, Raiatea.
That seems to be the case. Central Polynesia appears to have maintained more inter-island contact compared to some of the more peripheral regions, and consequently, their vessel designs, like the Pahi double canoe, remain closer to the large, sophisticated, plank-built voyaging types. Even though they might have lacked the truly enormous timber found in, say, Hawaii or New Zealand, they were masters of that lashed plank construction technique we talked about, building large, seaworthy hulls piece by piece. Early European accounts, like Quiros visiting the region in the early 1600s, were deeply impressed. He wrote their vessels were so subtly contrived that better could not have been made in Castile. High praise. Captain Cook also documented impressive double canoes there, over 50 feet long, still in use for significant inter-island voyages in the late 18th century. The demand was still there.
Okay, so central Polynesia kept the voyaging flame alive, so to speak. What about West Polynesia, Samoa, Tonga, where the whole voyaging tradition likely originated?
Right, West Polynesia is often seen as the cradle. They likely maintained the greatest continuity with the very earliest designs and were renowned for their seamanship. Tongan navigators, in particular, maintained influence over vast distances, even exerting control over parts of Fiji. That requires serious maritime capability. Samoan canoes, like the Aulia double canoe, were known for being fast around 7 knots, often made with dugout sections combined with sewn planks. They even used larger canoes to transport smaller fishing canoes, like the highly specialized va'alo for bonito fishing, out to distant grounds. That va'alo itself showcased incredible craftsmanship with perfectly flush planking. And Tongan canoes, the kalia, were legendary. Highly engineered, incredibly fast, supposedly over 11 knots, with some double canoes reaching that massive 28-meter length. Their influence was so strong, it apparently spread to designs in parts of Melanesia and Micronesia, too. They were a real maritime power.
Now let's jump north to Hawaii. Isolated at the top of the triangle. How did their canoes evolve differently? They had big trees, right?
They did. Hawaii had access to large koa trees and others, plus driftwood from North America. This abundance of large timber influenced their primary construction method. Hawaiian canoes typically started with a substantial dugout log base. Then, to get the necessary height and shape, they would add upper sections, strakes made of planks, lashed onto the dugout base. It was perhaps a more efficient use of large timber compared to building entirely from smaller planks, especially once the primary needs shifted from extreme long-distance voyaging to inter-island transport within the Hawaiian chain, warfare, or ceremony.
So less need for those huge ocean-crossing double canoes after they became isolated?
The need for routine trans-Pacific voyages likely diminished after contact with central Polynesia waned, probably around the 14th century, but they still built very large canoes, some 60 or 70 feet long. These were important for chiefly status, for moving armies between islands, and for large-scale fishing or ceremonial purposes. And we shouldn't assume contact completely stopped overnight. There's intriguing archaeological evidence, basalt adze from Hawaii found far away in the Tuamotu archipelago, suggesting that some long-distance voyages continued, even if they became less frequent.
Okay, now down to the bottom corner of the triangle, Aotearoa, New Zealand. The environment there is totally different, much colder, non-tropical. How did that impact Maori canoe design?
The sources suggest quite a divergence. A very significant divergence, yes. New Zealand's unique environment played a huge role. Its large, tectonically active islands, not small volcanic specks or coral atolls. The cooler climate meant that some staple Polynesian crops, like breadfruit or coconut, didn't thrive as well, pushing Maori society towards greater reliance on hunting, fishing, and gathering local resources. This shift is reflected in their canoes, or waka. Like in Hawaii, they utilized large timber for dugout bases. But interestingly, they largely abandoned the outrigger. And while double hulls existed, wakahua, they seem less common than elsewhere, perhaps often being two single hulls temporarily lashed together for specific journeys. Sails also seem to have been used less extensively compared to tropical Polynesia.
So mostly single-hulled, paddle-driven canoes.
Predominantly, yes, but that doesn't mean they were inferior. They were highly adapted to local conditions and needs. The Wakatawa, the war canoes, were magnificent achievements. Huge, elaborately carved vessels, sometimes over 100 feet long, capable of carrying 100 warriors. Perfect for coastal raiding or transporting groups along rivers and coastlines in Aotearoa's rugged landscape. They also had specialized fishing canoes, wakatete, and smaller river canoes, wakatuai. The relative lack of emphasis on sails might reflect the rougher seas around New Zealand, where paddling offered more control, or simply that the primary function shifted from open ocean exploration to coastal and riverine transport and warfare.
And finally, the most extreme case of adaptation. Rapa Nui, Easter Island. Utterly isolated and facing severe resource limits.
Rapa Nui is a truly poignant example of environmental constraints shaping technology. Their canoes were apparently much smaller and arguably less seaworthy than elsewhere. Critically, they lacked large timber suitable for dugout bases. The famous Rapa Nui palms, it turns out, weren't good for canoe building, so they had to construct their canoes entirely from small planks, painstakingly fitted and lashed together. Sources suggest they leaked badly, possibly due to a lack of good caulking materials on the resource-poor island.
And no sails.
Apparently not. Reports indicate they were entirely paddle-driven. This represents a significant technological simplification compared to their voyaging ancestors. It reflects their complete isolation after the initial settlement around 1250 CE. Genetic studies show no further outside contact until Europeans arrived. Their canoes became purely functional tools for nearshore fishing, which was vital because the island's marine environment wasn't particularly rich compared to tropical lagoons. It's a stark reminder of how isolation and resource depletion can lead to the loss, or rather the transformation, of complex technologies.
It's fascinating to trace those adaptations. But the story doesn't just end in the past, does it? Polynesian navigation isn't just a historical curiosity. It's a living legacy, something being actively revived and celebrated today.
Indeed. The last few decades have seen a remarkable resurgence of interest and practice in traditional Polynesian wayfinding. It's been driven partly by academic research, but crucially also by a powerful cultural revitalization movement across the Pacific. It's about reclaiming heritage, demonstrating ancestral skill, and reasserting cultural identity.
This is where things like the Polynesian Voyaging Society and the Hukule Canoe come in, right? This wasn't just reading old texts. It was about actually doing it again.
Exactly. The Polynesian Voyaging Society, co-founded by people like anthropologist Ben Finney, had a clear goal: to prove beyond doubt that the long-distance intentional voyages were possible using traditional methods. So they built Hukulia, a performance-accurate replica of a Polynesian double-hulled voyaging canoe. And in 1976, they sailed it from Hawaii to Tahiti, a journey of thousands of miles using only traditional non-instrument navigation. No compass, no sextant, no GPS, just stars, swells, wind, clouds, everything we've been talking about.
And they made it.
They made it. It was a landmark achievement. It silenced many skeptics and powerfully demonstrated the efficacy of the ancient techniques. But what's really poignant is how they relearned the techniques.
It had been lost in Hawaii.
Largely, yes. The full integrated system of non-instrument navigation had faded in many parts of Polynesia due to colonization and the shift away from traditional voyaging. So, for the Hukule project, they had to bring in a master navigator from Micronesia, from the island of Sarawal, where the tradition had remained unbroken. A man named Maupielug. He didn't use charts or instruments. He carried the entire system in his head and senses. He taught Nainoa Thompson, who became the first modern Hawaiian to master these traditional wayfinding arts and navigate hukula. It was this incredible act of inter-island cultural sharing that made the revival possible.
That's an amazing story in itself. And this revival isn't just academic, is it? It's had a huge cultural impact.
Massive. Hukulia and subsequent voyages by it and other replica canoes across the Pacific have become powerful symbols of cultural pride and resilience. It's inspired communities throughout Polynesia and beyond. You even see echoes of it in popular culture like Disney's Moana, which, for all its fantasy elements, actually did a surprisingly respectful job of capturing the spirit of Polynesian wayfinding and exploration.
Yeah, it really brought that idea to a huge audience.
Yeah.
The sources also mention activities where people compare traditional navigation side by side with modern GPS. What does that comparison show us?
It really highlights the fundamental difference in approach. Modern navigation with GPS and compasses is about precise quantitative data. You follow numerical bearings 300 degrees northwest, say. You look at a digital map showing your exact coordinates calculated by satellites. It's external, precise, immediate.
Data-driven.
Exactly. Traditional navigation, on the other hand, is about synthesizing a vast amount of qualitative, soft data. It's about constant observation, interpretation, and intuitive integration of dozens of subtle environmental cues. It requires years, decades of intensive training, memorizing star paths, swell patterns, bird behaviors, cloud types, oral histories of voyages. It's about developing an incredibly deep, embodied understanding of the natural world, using all your senses. It's a different kind of intelligence, really, one that's deeply integrated, not just analytical.
It really makes you appreciate the complexity of what they were doing. It wasn't simple. It was just different.
Profoundly different. And it certainly challenges any notion that older civilizations were somehow less intelligent. Their technology wasn't in machines, it was in their minds, their senses, and their relationship with the world around them.
Hashtag outro.
So we've sailed across centuries and vast oceans in this deep dive. We've seen how Polynesian navigators were true pioneers, achieving these absolutely extraordinary feats of exploration and settlement. They weren't guided by technology as we know it, but by this incredibly intimate sensory understanding of their world. Their ability to read the subtle language of the ocean, the sky, the birds, the water itself, combined with their brilliant canoe designs, allowed them to master the Pacific.
It's a story that's not just about historical achievement, remarkable as that is. It's also a powerful reminder of human ingenuity, our adaptability, and the incredible depth of knowledge that can be built up over generations when people live in close, observant harmony with their environment. It really challenges our modern assumptions about what constitutes a map, how knowledge is passed on, and how deeply our intelligence can be intertwined with the world we inhabit. It's about embodied wisdom, not just data points.
So maybe as you go about your day, navigating your own world, take a moment, consider what subtle signals, what natural cues might you be missing in your own environment? Cues that could potentially guide you or offer unexpected insights. And think about what generations-old wisdom, maybe closer than you think, might be waiting to be rediscovered and applied in fresh ways to the challenges we face today.
Yeah, and perhaps this deep dive leaves us with a final thought to ponder. In our world, which is becoming so incredibly reliant on external technology for finding our way, for getting information, for understanding almost everything, what crucial human capabilities, what sensory acuities and observational skills are we perhaps allowing to atrophy? And in letting those skills fade, what profound connections, what deeper insights into our world might we be losing without even realizing it?